In this video, we will look at a couple of typical applications of linear equations. So for this first one here, Sam receives a $150 iTunes gift card for Christmas. Suppose each album she buys costs $7.50, and we want to let X be the number of albums purchased and Y the dollars remaining on her gift card. This relationship between X and Y is linear. So we want to first write a linear equation representing that relationship. Well, the amount of money Y that she'll have left, she will have left is, well, she starts with 150, and then she is losing money on the card because she's purchasing things, so minus, and then she's going to lose 750 per album. So if she buys X albums, she will lose $7.50 times X. Written differently, this is the same thing as negative 7.50x plus 150. You do not have to redo this writing, but people often like to do that so they can see the mx part first. So we've got a linear relationship between the number of albums purchased and the corresponding value on the card. What's the slope of this line? Well, notice the m value is specifically negative 7.50. So the slope is negative 7.50. Now, to add in this section, we want to interpret the meaning of the slope. Well, most people can quickly find out the meaning of the slope in this particular example, but the next one becomes a little bit more challenging. Because that negative 7.50, or not specifically the negative, but the 7.50 was already in the problem as the cost of each album, it's not very difficult to describe the meaning of this slope. Her overall amount of money on her card is going down, hence the negative, so she is losing $7.50 per album purchased. And by losing, I mean her overall value of her card is going down by that much. So she's losing $7.50 per album purchased. In the next problem, you'll see the interpretation of the slope is a little bit more challenging. Let's continue. What's the x-intercept of this line? Now recall, in y equals mx plus b form, m is the slope and b is the y-coordinate of the y-intercept. The x-intercept does not play a role in this form of the equation. So we now need to think back to when we first started working with the x-intercept. Again, the x-intercept of a line is where the line crosses the x-axis. We don't want to have to draw the line to do this. Instead, remember, any point on the x-axis has a y value of 0. So to find the x-intercept, we simply need to take our equation and plug in 0 for y. And plug in 0 for y. And now if we solve for x, we'll have the x-coordinate of our x-intercept. You can certainly subtract 150 from both sides, or differently, you could add 750x to both sides, giving me 750x on the left and 150 on the right. It doesn't matter if you wanted to subtract 150 from both sides to start, that's fine. I like to just be able to get rid of the negative numbers as soon as possible, but it's really up to you. And then from here to solve, you would divide both sides by 7.50 or 7.5, which is equivalent to that, and we get x equals 20. So the x-intercept is not 20. The x-intercept, again, is the ordered pair 20, comma, we found that 20 when y was 0. So what's the meaning of this? We're going to interpret its practical meaning. The practical meaning is not that this is the point on the x-axis where the line crosses. The practical meaning is, what does this mean for Sam in this scenario? Well, that 20 represents the number of purchases, albums purchased, and that 0 is the amount of money left. So don't write that as two different statements. Instead, say if Sam purchases 20 albums, then she has $0 left on her card. Then she has $0 left on her card. Or said differently, she can purchase 20 albums with that original gift card. Let's look at another example. In this scenario, this is real world data. Of all children aged 5 or less worldwide who have died, the main reason is due to malnutrition for 45% of them. The following table represents the number of underweight children globally. So in this case, X is the number of years since 1990. So an X value of 0 corresponds with the year 1990. So in 1990, the number of underweight children in the world was 160 million, because it says it's in millions. So in 1990, there were 160 million children around the world that were malnourished or underweight. X equals 12 corresponds with the year 2002, because you take 1990 and add 12 to that, that would put you at the year 2002. So this data point right here tells us that in 2002, there were 99 million kids worldwide that were underweight. So let's study this relationship. So part A says to use the slope formula to calculate the average rate of change per year. We want to find the average rate of change per year. So don't forget our slope M is equal to y2 minus y1 over x2 minus x1. So we only have 2 points here. I'll subtract the y values like that. 160 minus 99 over, subtract the x values in the same direction. So we'd have to do 0 minus 12. And here we get 160 minus 99 is 61. 0 minus 12 is negative 12. 61 divided by negative 12 is approximately negative 5.08. Typically in the past, we've just reduced fractions and left something like that. But because we're talking about slope in an application, I actually want to do the division. And you get approximately negative 5.08. So negative 5.08 is the slope. Now, what does that mean? So you can see the number 5.08 doesn't show up in the problem as it's initially stated. So it's a little bit more challenging to figure out what this means. But if you recall in a previous lesson, another way to think about slope is it's the change in y as x increases by 1. As x increases by 1. So that negative 5.08 is a change in y. Let's use the delta notation from a while ago. It's the change in y as x increases by 1. Let's think about this. So what are your y values? Well, your y values are the number of underweight children in millions. So that means that this is a number of children, the negative 5.08. And that number of children is going down because it's negative. So we can start this describing the average rate of change by the number of underweight children globally is going down, again, because it's negative. On average, 5.08 million. And then again, change in y as x increases by 1. So x is representing the number of years since 1990. So as x increases by 1 means as you go up by 1 year. So since 1990. So the number of underweight children is going down on average 5.08 million. You can always use the word per in describing a slope. The number of underweight children is going down on average 5.08 million per year since 1990. The 5.08 million, that's your change in y, i.e. specifically the slope. We also say it's going down because it's negative. And then it's the change in y as x goes up by 1. So per year is representing as x goes up by 1. And I also mentioned since 1990 because that's where the data started. Now that we have slope and we have the meaning of a slope, we can also write a linear equation for the situation. As you can see, we do not have a vertical line. We have a negative 5.08 for the slope. we can write this in the form y equals mx plus b. Well, we just found m. It's approximately negative 5.08 times x plus, we need the value of b. But if you notice right here, this point is the y-intercept. 0, 160 is on the y-axis, so the b value is precisely that 160. So we have y equals negative 5.08x plus 160 represents this relationship between the number of years since 1990 and the number of underweight children around the world in millions.